Azoth focuses on small, complex metal parts. We utilize sinter-based additive manufacturing as a process. Processes like material jetting, binder jetting, material extrusion. But so often we're talking about the printing process, not the sintering process. And sintering is really where the magic happens. In metal-based AM, what we're doing is we're printing a green geometry, roughly 15 to 20% oversized depending on the process and material. And then we go into a process called sintering. In sintering, we heat the parts up to near their melting temperature. We hold for a prescribed amount of time, typically 15 to 20 hours. And then the parts cool down, and what comes out is a fully dense metal part. They shrink about 15 to 20% during that time. So at Azoth, what we're doing behind the scenes is we're scaling your part up for that shrinkage factor. We're considering a cycle based on your material, the cross section, the dimensions that you want, and we're custom tuning a specific cycle. And when we talk about industry known standards and operating to standards from the metal injection molding industry, it's what happens in your furnace that really enables you to get those mechanical properties. A couple things to consider as an end user. You want to work with a manufacturer that has the ability to design a sintering cycle, to design supports for your sintering cycle that result in the mechanical properties you desire. There's variation in a furnace. You want to work with somebody that can account for that variation and make sure your dimensional control is tight enough for the parts that you're putting into production. So this is all stuff Azoth does behind the scenes so that you're getting the CAD model that you upload to our site. If we peel back the layers a little bit, you can imagine if you were to heat your part up to near its melting temperature, what it's going to want to do is distort. So if we use an example like this part, it's kind of like a bridge. If that bridge is heated near the melting temperature, what's it going to want to do? The middle of the bridge is going to want to sag. So Azoth designs what we call live setters to contradict that. Essentially, we print the inside of the bridge, we put the part on the bridge. Now, as the part is heated up and it starts to densify, it can't distort because there's a bridge under there. It's things like this. It's designing supports. It's thinking about the cross-section of your part. It's looking at the blueprint to understand dimensional control that needs to be considered when sintering. To expand on sintering, it's done oftentimes in either a belt furnace, which is a long continuous furnace, or a vacuum furnace, a batch furnace. And that's what we utilize here at Azoth. We utilize a vacuum furnace capable of creating atmospheres in partial vacuum, and nitrogen, argon, and hydrogen, and capable of going up to temperatures around 1400 degrees Celsius, which allow us to create custom cycles to sinter your components.